Yeah, let's discuss a question from heat transfer about the spectral power density and stuff like that. So what is given is the power radiated by black body is P. Now recalling that the power radiated by black body is basically given as sigma A T power 4. So this is the black body power emission, and it says that it radiates maximum energy around wavelength lambda naught. So recalling those graphs from the Planck's distribution law, you will get to know that the emissive power, which is E, okay, and how it varies with the wavelength lambda. So if you recall, there are the wavelengths vary like this. I mean the variation of the emissive power with the wavelength is like this, and these are with different temperatures. Let's say 500 Kelvin, then 800 Kelvin, then 1000 Kelvin, and then 5000 Kelvin, which is basically the sun's temperature. Okay, around the sun, so this is 5000. Okay, so what it basically means is that it means that as temperature is increased, you will be getting the peak power radiation at a lower wavelengths. That's what it means. Okay, so this is actually captured, all these peak points are captured in a equation given by Wien's law, which basically says that lambda max to the power lambda max into T is constant. That means the wavelength corresponding to the spectral power is lambda max into T is constant. So in case 1, when the lambda is lambda naught, let's say the temperature is T naught, and this is constant. And in a case 2, when the wavelength is reduced to 3 lambda by 4, let's say the temperature obviously will increase going by this law, that is T1 is equal to constant. Okay, so when we equate these two, lambda naught T naught, because the constant will be same in both the cases, so when I equate this, the T1 is basically 4 T naught by 3. That is what is your T1, 4 T naught by 3. Okay, let me write it clearly. 4 T naught by 3. So this is my temperature T1. So the new power, let's call it P1, the emissive power, is given as sigma A T1 power 4. So this is my new power. So when I take this equation as well as this equation, and when I take the ratio P by P1 is equal to T by T1, or in fact T naught, because you have it here initially temperature T naught, so T naught by T1 whole power 4. This is what I get it. Okay, so T naught by T1, based on the ratio we get 3 by 4. Based on this equation, we get 3 by 4 power 4, which is nothing but 81 to the power of 256. So the new power P1 will be 256 by 81 power of P is 256. So the option for this is D, 256 by 81. Thank you.